Hello everyone, welcome to Mansi Sky, and today's video is specially for science students 11th and 12th because we are going to discuss physics practical, which is thermistor. Thermistor is one of very important practical from the physics, and as a science student you know the importance of practicals and the marks we get from the practicals. So we are going to discuss each and everything. We have diagram here, then we have procedure, aim, apparatus, formula, everything. Then we have the graph, and then we have the real observation of this experiment. Like I have the real results got from the after doing the experiment. So yeah, these are not fake, these are the real resistance value I got from the experiment. Okay, first we are going to start from the understanding the diagram of this practical. This practical is called as thermistor, or it has name called to study the characteristics of the thermistor. So the aim is to study the characteristics of the thermistor. So the first thing we are going to see is the diagram. What is in the diagram here? As you can see, there is many things in this diagram. We have a beaker, then we have the stand, then we have the burner. Okay, these are the very essential things in the physics laboratory. Then we have the stand. Okay, and very important, we have very important three things, which are, first is our thermistor, then we have our thermometer, and then we have our digital multimeter, which is called as DMM, or simply you can say multimeter. Okay, multimeter, why here is multimeter? Because with the help of multimeter we are going to find the resistance. Okay, we are going to make the graph of temperature against the resistance. So we have to check the resistance and note down the resistance according to the temperature. Okay, so let me explain the diagram here. We have a burner and a stand and a beaker over the burner. Okay, we have put in some water here, okay, and then as you can see, there is one thing in like this. It is in the circle form or a circular form, and this circular form thing is nothing but our thermistor. Thermistor is a very small thing. It is also called as bead type thermistor. So we are going for the bead type thermistor here. So this is our thermistor. Then we have here water, and as you can see, from the thermistor we have connected our DMM, which is multimeter. So multimeter is connected to what? Thermistor. And then we have a stand, and from the stand we connected the thermometer here. So the rough diagram of the practical is something like this. A thermometer, okay, a thermometer is in the water, a thermistor is connected, a thermometer is connected to the DMM, and the thermometer is inserted in the water. Okay, and the burner is started here. Okay, so this is the diagram or the setup of our experiment. Let's move on the next page. Okay, then we have the aim, apparatus, and the formula for the thermistor. Okay, what is the aim of this thermistor experiment? Writing aim is the simplest thing, and by writing or reading aim we know what to do in the practical or what to do in the experiment. So that's why the aim is very important. So aim in this whole experiment, or aim of this experiment, is nothing but to study the characteristics of the thermistor. We are going to study the characteristics of the thermistor. Okay, then we have the apparatus. Which things we have in the apparatus? First is bead type thermistor, then battery, then millimeter, then connecting wires, beaker, thermometer, and burner. So you don't have to read or learn the apparatus, because as you in the examination you will be providing all the apparatus used for this experiment. So you just have to see them, watch them, and you have to write down the name of them in the apparatus column. So that's why you don't have to learn the all apparatus. Okay, then we have formula. What is formula? For finding the coefficient of resistance. Okay, find the coefficient of resistance. As we have to find here the alpha. Okay, we have to find here what? Alpha. We have to find what? We have to find alpha, and the formula for finding the alpha is nothing but R2 minus R1 divided by R1 into T2 minus T1. Okay, I will be explaining this formula after some time, because when we will be studying the observation table, this formula is very helpful for understanding the table also, and the table is very helpful to understand the formula. Okay, I will be just telling you these things. D is nothing but coefficient of resistance. That then what is R1? R1 is what? Resistance at temperature T1, and R2 is resistance at temperature T2. Okay, then we have the graph of it. As you are an 11th standard students or a 12th standard student, I hope you know how to make the graph. So this is a rough idea of how to make the graph I will be telling you. Okay, we have first we will be having x-axis and y-axis. Okay, then you have to plot the temperature on the x-axis and resistance on the y-axis, and then you have to plot the graph. Okay, this is the procedure. You can read the procedure from this page, so I don't think I have to explain this. Then a very important thing, which is observation. What observation we get from this experiment? Observation, first observation you have to write is always least count of the apparatus. Okay, whenever you will be performing any type of experiment from the apparatus, from the physics practical, first thing you have to calculate is least count. How to calculate least count? I hope that you know how to calculate the least count. Okay, what is the least count of a thermistor? What is the least count of thermometer? It should be thermometer here, not thermistor. Okay, so least count of the thermometer. Okay, least count of the thermometer is what? 1 degree Celsius. 1 degree Celsius is the least count of the thermometer. Then we have very important thing, which is our chart. Okay, we have to start taking reading from temperature 40 degrees Celsius. When the thermometer will hit the temperature 40 degree, then after you have to start to take the to note down the resistance. Okay, at 40 degrees Celsius, what I got? At 40 degrees Celsius I got 716 resistance. Okay, 716 resistance, or 716 ohm resistance we got. Then at 50 we got 572, which is 572. Then at 60 we got 446 ohms. Okay, then at 70 degree we got 350 ohm. Then at 80 degree we have 273 ohm. Okay, by watching this or by observing this table, what you get? We can see that when the temperature increases, as the temperature increases, okay, we have temperature T and resistance RC. When temperature increases, the resistance decreases. You can see this in front of your eyes because the observation table is here. See, when the temperature increases from 40, 50, 60, 70 to 80, the resistance decreases. When the resistance is on 516, it becomes 572, then 446, and just like that it decreases. So the main result we get from this whole chart is nothing but when the temperature increases, resistance decreases. Then we have the calculation part, as we have to find the alpha. Okay, what is alpha? Or coefficient of resistance. Alpha, D, or anything you can assume for coefficient of resistance. Okay, for how to find the coefficient of the resistance? We have the formula for it, which is R2 minus R1 divided by R1 T2 minus T1. Let me tell you what is R2. Okay, R2 is nothing but last resistance. Okay, last resistance is what? R2. So this is our last resistance, and what is R1? This is our R1. Okay, let me write it. This is our R1, this is our R2. Okay, then what is your T2 and T1? The first temperature is definitely T1. Okay, the first temperature is going to be T1 and the last temperature is going to be T2. Okay, so this is going to be T1 and this is going to be T2. So in this way you can see or find the R2, R1 and T2 and T1. Okay, now we have to solve it for finding the coefficient of the resistance. How to find it? With this formula you have to just minus R1 from R2. Like we have to minus 273 from, we have to minus 716 from 273 as it is given here. Okay, so it is given here, the calculation is given here. You have to use the log table for it. You are not allowed to use any type of calculator or any type of phone calculator. You have to use log table for finding all the values. Okay, so by calculating and by finding all the values and dividing it, we got the answer of our coefficient of resistance. What is our coefficient of resistance? The value of our coefficient of resistance is nothing but 0.0146 degree Celsius. So this is our answer of D alpha, or coefficient of the resistance. At the last page we have the result. Okay, what is result actually is? Result is nothing but what you got from the experiment. So what two things we got from the experiment? First thing was, as the temperature increases, the resistance decreases. So we have that first resistance here, first result here, first result is nothing but resistance of thermistor decrease as the temperature increase, or you can simply write that as the temperature increase, the resistance decrease. And the next result we got, which is temperature coefficient of the resistance. The coefficient of the resistance is 0.01546 degrees Celsius, or you can simply write that value of coefficient of resistance is nothing but 0.01546 degrees Celsius. Okay. So in this way we have completed our thermistor practical, which is a very important practical from the physics. Okay, if you love the video, if you love the channel, then just subscribe to our channel, because many practical videos, many important study related videos are coming on this channel. So thanks for watching.